Okay, good morning to one and all. So today we have a class on index numbers and its basics. Index numbers are very important topics. We have one of the important topics in statistics. We have a basic glimpse in this particular PPT we have. Now, index numbers measures the relative changes in price, comma quantity, comma value or some other item of interest from one point period to another. And one more definition regarding index number is a simple index number measures the relative changes in just one variable. Here we have some types of index numbers, that is unweighted index numbers, weighted index numbers, and in Fisher's index number, value index number, and a special purpose of index numbers. In unweighted index numbers, we have special average of the price indexes, simple aggregate index, and in weighted indexes, we have last year's index and Patches index. Apart from this, we have Fisher's price index number, value index number, and special purpose index number. In special purpose index number, we have consumer price index number, producers in price index number. So these are some formulas related to unweighted index numbers. This is first formula for simple average of the price relatives. So this is simple average of the price relatives. It is represented by P equal to summation Pi divided by N. That means it is the ratio of sum of the prices and number of items, sum of the prices of the items and the number of items. And here we have one more formula related to simple aggregate index. Simple aggregate index equal to P equal to summation P divided by summation P naught, where summation PT represents the sum of the prices rather than the indices, and P0 represents sum of the prices of the base period. This is the formula for simple aggregate. And we have some definitions related to last year's and Patches. So last year's is also called as base year index number, and Patches index number is also called as current year index number, because last year's requires the quantity data from only the base periods. It consumes or it requires the data related to base period only. And when it comes to Patches, it considers the data related to current periods. And this is the example for simple price index number. Simple price index number, sum of all prices divided by number of commodities. We have prices in the base year and current year and their product. If you consider these things, it will give you the ratio of summation Pi by N, the P equal to 108. This is the last year's formula. This is last year formula. Last year's index number is also called as base year index number. Why? Because it consumes in denominator we have the product of base year and base year prices and quantities. So this is the formula, a basic formula for last year's price index number. That is P equal to summation P into Q naught divided by P naught into Q naught into 100. Here we have the terms explanation related to the last year's index number, that is P. P is the price index number. This is the price index number, and PT is the current price, P0 is the base price, and Q0 is the base year quantity. Base year quantity. Since it consumes only the base year prices and quantity, does not consider the current year quantities. So it is called base year index number. And second formula we have Patches price index number. Patches price index equal to P equal to PT into QT divided by P0 into QT, where P is the price index and PT is the price index of current price, and this is the current quantity, base year price and base current year quantity. It consumes current year prices and current year quantity. So it is called as current year index number. And this is the simple example related to last year index number. This is the Patches index number. One more index number we have, very important index number that is Fisher's index number. So it is also called as Fisher's ideal index number. It is also called as Fisher's ideal index number. So because it satisfies test of adequacy, maximum of the test, just like time reversal test, circular test, and unit test. So it is called it satisfies maximum of the test criteria. So it is called Fisher ideal index number. It is geometric mean of last year's and Patches The formula of Fisher's index number is Fisher's index equal to last Pierce index and Patch's index number and its geometric mean. If you consider the geometric mean of last Pierce and Patch's, then you can obtain the Fisher's index number. This is the example of Fisher's index number. You can directly calculate Fisher's index number. And when it comes to special purpose index number, we have a value index number. So value index number measures the changes in both the price and quantities which are involved. A value index such as the index of departmental store. For example, if you consider the departmental store needs the original base year prices, the original base year quantities, the present year prices and the present year quantities. That means the current year prices and the current year quantities. And the formula is value index number equal to summation P into QT. T represents the current year and 0 represents the base year. The product of sum of products of the current year prices and quantity and the sum of product of base year prices and quantity. So finally, we can say that value index number equal to, it is the ratio of sum of product of current year prices and quantity and the sum of product of base year and current year quantity. So this is the value index number. This is the example related to value index number. We have a data in dollars, that is some ties, suits, shoes. This is the prices in 2000 and quantity sold in 2000. And this is the product of base year prices and base year quantities. In 2005, we have the same commodities prices like this and quantities like this. These are the product of base year, current year quantities and current year prices. These are their total values. And now if you consider the value, that is sum of PT into QT divided by P0 into Q0 into 100, it gives you 117.8. So we have a consumer price index. So one of the important special index number is consumer price index number. Consumer price index number allows to determine very important line, that is effect of prices increase on the purchasing power of a money, purchasing power of a rupee, or purchasing power of a dollar, or purchasing power of a currency. We can say anything. So just like that, if we want to measure the purchasing power, then we need to be calculate the consumer price index number. And one more important use of consumer price index number is it is revising the wages, pensions, and payment systems. So regarding salaries, wages, pensions, and payment systems, if you want to revise these things related to a particular year, then we need to use consumer price index number. And one more, the third is it is an economic indicator of the rates of inflation of the any country, not only United States, not only India, and maximum of the countries they are using consumer price index number, economic indicator, how the economics are going to be changed and their values are going to be changed. And the next thing is it computes a real income. A real income equal to money income divided by consumer price into 100. This is the formula which is we have for calculating consumer price index number. And here we have consumer price index number. For calculating consumer price index number, we have some formulas. Number one is real income. Tarvata, by using index number as a deflator, using index number to find purchasing power. So real, and if you want to calculate the real income by using consumer price index number, we have that is money income divided by CPI into 100. And deflated, and if you want to calculate deflated income or deflated sales, actual sales or actual income divided by an appropriate index into 100. It gives you deflated sales. And purchasing power of a rupee or dollar, it gives you divided by CPI into 1000. Thank you.